Hi, my name is Jean-Jacques and I'd like to give you a short introduction about a new pattern called the SAM pattern. So, to give you a little bit of context, I believe many of us are involved in building modern graphical user interfaces that provide, enhance user experience. And what we can see is that network events are becoming as prevalent as user events. You need to handle events from your friends, players, wearables, IoT sensors, and they all have, side effects and need to render elements of the view. And you need really to think about the view as a dynamic, as part of a dynamic distributed system. So the goal of this talk is to provide a new way to think about front-end architecture using a new pattern called the SAM pattern. So let's step back, let's look at how we've been writing code for front-end architecture, and that code has probably not changed for decades. When in the early days of Windows or even the Mac, or Next for people who have been around that long. What you can see is that you know writing code for GUIs has been pretty straightforward. It's based on events and callbacks or events and events handlers, and in web application, that code tend to have a lot of problems. So if we take the example of drawing a rectangle, we have three events, mouse down, mouse move, mouse up. And typically this code is hard to compose because all those functions are defined, as a list of functions, and they tend to rely on global variables as well. So this is not leading to a way where you can easily slice and dice your code in reusable components. At the same time, you need to think constantly about subscribing and unsubscribing to those events, and wiring them to the right handlers. And that requires a lot of energy and can create some bugs. Um, there is a poor separation of concern because you often those handlers manipulate the DOM directly, and here you would draw the rectangle in a canvas, for instance. Um, this type of code also leads to subtle bugs in terms of data consistency because you're updating global variables, and as multiple events need to be processed concurrently. And of course, I know that JavaScript is a kind of single-threaded, but based on um, how you write your code, what will happen is you might be waiting on some IOs, and at that point the thread quote changes, and you start processing multiple events concurrently, and that can lead to subtle data consistency bugs. So overall, that code is hard to debug, hard to maintain, hard to reason about, and people have been looking for an alternative. So after some intense research, the industry, companies like Facebook and Google came out, about 3-4 years ago with new frameworks. I'm sure everyone has heard of React and Angular. And at a high level, what those framework has done is they just put a box around that code and wrapped it into a component or a class. And then the true innovation is they created a kind of a change detection mechanism. And when the data changes, then they re-render the component. And that's pretty much it. That's what Angular or React has done. They do it in a different way, but at a high level, this is where the industry is going. And there are issues with that. One of the big issue is now the data model is completely fragmented because each component holds a little piece of it, and by detecting changes to that piece, then it re-renders itself in a global context. And that has not worked well, and people are now looking for alternatives to that basic component model. And the main direction for looking at those alternatives is to look at functional reactive programming. So we had reactive frameworks, but they were not necessarily functional. They had some elements of FRP, but not truly being FRP based. So there are many definitions of FRP, and here I just would like to use this one because I feel it's closer to where the direction is going, where the industry is going in terms of front-end architectures. And really what people are trying to do is to build programs in a declarative way by defining event streams, how they link together, and what happens if a new stream value arrives on time, over time. So that's pretty much what people are trying to do, either with, say, Redux or Elm or Cycle.js, kind of the newer approaches to front-end architecture. However, the problem I have with this approach is that they tend to ignore mutation. They hide it and pretend that application state mutation somehow doesn't happen. And we'll know that it does. So how's that possible? Well, in reality, frameworks like Cycle.js, for instance, bury the application state inside a stream, and it becomes, in my opinion, really hard to reason about. So let's look a little bit at how those frameworks have evolved and where they're heading. So first, I like this tweet. I'm not the only one, apparently. Sam Stephenson is a developer at 37 Signals, and I think he summed up a bit where the industry is heading right now. And 10 plus years ago, life was relatively simple. It was kind of the years of MVC and JSP and ASP and struts and whatnot. And after all this research in the past 3-5 years, this is where we're heading. And I'm not sure this is, so first, it's not really representative of where we are today, but in a way, it seems that, if you look at Redux, for instance, with all the libraries you can add to solve different problems, thunks and sagas and whatnot, it starts looking a little bit like that, and I would say we probably have to be careful that it doesn't end up looking like that. Part of the journey to understand modern front-end architecture is to focus on semantics. And I really would like to convey the message that semantics matter. You look at Redux, for instance, an action in Redux is a data structure, nothing else. They have action creators, which are functions, but those functions are called action creators. They create actions, which are data structures. And if you look at this other definition from Lee Byron, who's also working at Facebook, but he works on a different framework, immutable.js, he has a completely different view on what an action is. For him, an action is a function that takes the application state and results in a new application state. And actually, I disagree with that definition as well. It's not correct. And let me take a very simple example. Let's say you go to visit this beautiful fountain in Portland. It's the Ira Keller fountain. And you just add water to the fountain. And you should ask yourself the question, I just applied an action, such as adding water to the fountain. And what part exactly decided of the resulting application state? Is it the fountain or is it the action? And I probably would guess that you would conclude that the fountain decided of the resulting application state because it has the full knowledge of the model and it can decide really what is the application state, not the action, which would be, I want to add a gallon of water or something like that. So let's look at the semantics of some of the popular framework before we dive into the SAM pattern so that you get a sense that semantics are very important and you have to be very careful as to how you define those semantics. So if we look at Angular 2, I know this is some React code, but Angular looks fairly similar except that the render function is based on a template, not on some JavaScript function /JSX. You have a component model. The component has events, and when changes happen to the component data model, then those changes are reflected in the view by a reactive loop that will update the view based on the template definition. At this point, I would like to emphasize that templates, in my opinion, are the new Flash. They are on the way out, and you should be very careful as to how you use template. I like Angular too, don't get me wrong, but you should be very, very careful as to how you use templates. The DSLs, they're interpreted. React has showed us there's a much better model. It's a functional HTML. It's really expressing the view as a function of the model, and this is where the industry is going. There's just no other way. Now, if we look at another framework called MobX, this framework is also reactive. It's also added a little bit of functional aspect to it recently. What you have to understand is that the semantics of MobX are really focused on rendering the view. In other words, when you make data changes, those data changes can be wired to observables. From there, you can use computables to compute what the view will look like, and then make a reaction to render the view. However, I really would like to emphasize that MobX suggests that all your business logic should be outside pretty much the framework itself. Um, you know, the event handler up to the point where you start rendering the view is outside MobX. And again, they've added the concept of action. In my opinion, they're not action, they're mutation. And that's where the functional aspect come into play. But you have to be very careful as to where you write your business logic, and understand precisely the semantics of the framework that you're using. The next framework, I know people call it a library, but in my opinion, when you use React plus Redux plus a lot of other things, you're really using a framework, not a library. And here we start seeing a picture that's a lot more complete, a lot closer to the FRP. So as I mentioned earlier, a Redux action is, for me, not an action. A data structure is not an action, period. It is an intent. And the true action is somehow coupled with the mutation inside the reducer. And that's the functional aspect of Redux. And as you start noticing, now the model is externalized from the components. In other words, even though React components have their own set of properties, what's happening is Redux is creating a unidirectional data flow and is externalizing most of those properties from the components in order to be able to reason about them. So we somehow back into kind of globals, but in a way that's a much better factored compared to the original code I showed you. And then React is, of course, reactive by design. Once Redux and the reducer have mutated the application state, the store gets updated, and that's when the components get rendered. Now, again, in other words of caution, when you use Redux, you probably end up using a lot of other things, such as thunks and sagas and whatnot, and those semantics become very complex. In my opinion, the framework is a little bit out of control at this point. There's just too many moving parts, and I've never seen. It's a cool framework. It has a lot of tension and interest, but I never saw someone saying, "Oh, it was easy to build anything with React and Redux." The last framework I'd like to talk about is Elm, because this is probably the purest FRP framework that you would find. And actually, Elm is also its own language that transpiles into JavaScript. And so Elm has signals/streams modeled as subscriptions. It has an update section where all the application state get mutated, and it's so pure, so functionally pure, that all the side effects are handled as data. And then once the update occurs, and the view is reactively rendered. Again, I'm not necessarily a big fan of a pure FRP approach, but this is probably as close as you would ever get to FRP if you're looking for what it means to have an FRP framework. Now, I wouldn't get too excited about FRP because FRP doesn't work yet over network boundaries. People have made FRP work within a single node. Uh, the glitches that people have experienced at the beginning of FRP have somehow disappeared because the way updates are done, they are somehow structured along a dependency graph that would make sure that there's no glitches as you update the data. However, over network boundaries, the property of network calls, failures, latency, ordering, message ordering, make it just impossible to use the same FRP concepts, and you just have to break away from FRP as soon as you cross a network boundary, which I would guess is always when you build a front-end architecture. So I'd like to introduce SAM, the state action model pattern. SAM is taking about a 180-degree view from FRP. It's not trying to hide application state mutation. It's trying to make it a first-class citizen of the programming model. And let's look at how it does that. So first, SAM is trying, like everyone else, to answer the question, what happens when an event is triggered and we need to update the model? From the model to the view, SAM is taking the modern approach of React, which is you should use functional HTML or functional rendering of the view. The view is a function of the model, period. Anything else is simply not as elegant. If you use templates like in Angular, you should be really, really careful as to why you would want to do that compared to a functional HTML approach. So in order to understand SAM, you need to understand a couple formalism. The first one is the Paxos protocol, and both formalism were created by Dr. Lamport, who's a researcher at Microsoft. He spent his entire career working on those formalisms, and it's a truly exceptional work. And if you're not familiar with both Paxos and TLA Plus, that I'll speak after, you should really take a look at it because it's really worth knowing about. So the Paxos protocol is a protocol that helps you achieve data consistency in distributed system, as in eventual data consistency, and it's consensus-based protocol. So it has three roles: a proposer that creates proposal, acceptor that accepts the proposal to mutate the state, and then learners, which when the data that has been accepted will access the new state and render or notify whoever needs to know about the new application state. And the SAM pattern, which actually could be renamed the PAL pattern, has a direct relationship to Paxos. Actions are proposers, model is acceptor, and the state function is learner. Some people in the SAM community have suggested actually to rename it PAL, and I'll probably put it for a vote, just to make sure people are comfortable, going in that direction. So how is it that mutation becomes a first-class citizen? So we have to look at TLA Plus for that. TLA Plus stands for the temporal logic of action, and it describes how we mutate states. So if we take the simplest model, a counter, and inside the event handler, as the user move the mouse or click the mouse or click on a button, most developers would write the state mutation as counter equal counter plus 1. In reality, this is not how mutation occurs. And if you look at TLA Plus says, well, the first thing you need to do is to create a proposal. And of course, the proposal would be counter plus 1. And then you would want the counter to accept this value. And you don't just assign it. You truly ask the counter to accept the value. Only the model can decide whether that proposal can be accepted. It has full knowledge of the data model, the application state, to decide whether the new proposal is an acceptable value or not, and it could potentially reject it. But the proposal can be designed in ways that doesn't need the entirety of the model to understand whether it will be accepted or not. Once it's accepted, then the learner or a function will take the accepted values, the new application state, and do something with it, such as render the view as a function of the model. So in SAM, that's all you need to know. It's really all you need to know. There is nothing else you need to know. It's about factoring your business logic in ways where proposers propose values to an acceptor, the model, or multiple acceptors in some cases. And once the model is accepted or rejected, the values, then the learners are invoked to do something with it. And that's it. It's really as simple as that. Um, so if we look slightly more detailed, as I mentioned, proposers are called actions. The acceptors are the model, and there's usually one in most cases. And then Sam introducing the state function, which is a learner. And sometimes people have expressed some difficulty to understand what is the state function. And really what Sam is saying is that the application state is not just the model, which is some property values. It's actually a combination of the property values and a function that I call the state function that decide in which state the system is. And the way you think about state is like the state of a car. When you apply an action, which is to start the car, you don't know if the car will start when you actually apply the action. And the state function decide whether the car is started. For instance, you can have a modern car, Tesla, for instance, that says, no, the car is not started because it doesn't have enough energy to go where you want to go, so I'm not going to start. Why would you start the car when you know you cannot reach your destination? So what I want to emphasize is, in that case, the model would have the battery level, it would have the destination where you want to go, but the state function will decide the car cannot start because it cannot go where you want to go. And so that is the relationship between the model and the state function, and this is something that's very important. Once, one of the role of the state function is to trigger the rendering, to create the state representation, and in particular, to trigger the rendering of the model of the view as a function of the model. Another important aspect of the state function is actually to compute whether there is a next action that needs to be performed. So let's say now you need to launch a rocket, you're designing a rocket launcher, and as the countdown reaches 0, now you reach the state where you're ready to launch. And therefore the next action is to invoke an action called launch. And that's the purpose of the next action predicate, is to compute based on the model property values and the current control state if there are anything else you need to do. And that logic wouldn't fit really well in the model. It wouldn't fit really well in the view. And that's why it's very important to have a mediator between the model and the view such that they fully decouple. And that's another, key outcome of the pattern, is that now the view and the model are pretty much 100% decoupled in SAM. So from a component perspective, SAM is made up of a number of parts. Of course, the view are decomposed into components, and I really want to emphasize the components know nothing about the underlying business logic, the actions, the model, and the state. And that's a really, really important outcome of using the SAM pattern. Then events are wired to actions. There are many different ways to achieve that. You could have this wiring generated in the state function when the view is created as a function of the model. Each component can then be wired properly at that stage. You could have a dispatcher. You could, literally have a number of ways to do that. That's another important outcome of SAM is wiring agnostic. And you should be a little bit suspicious if your programming model depends on the way you wire the elements of the pattern or the programming model. So we have actions. All those actions can be independent of each other because the proposers, they create proposals. They don't know very much. They're really about translating an event or an intent into a unit of work, a call to a unit of work within the model. And they do that by creating a proposal. The model itself is decomposed in many units of work, and there's a many-to-one or many-to-many relationship between actions and units of work. A unit of work is basically deciding how the application state mutates as a unit of work when in response to a proposal. Once the model is mutated, then the state function is invoked. And again, the state function will quickly decide what state the system is in whether you started or stop or forward, launch, etc. And then from there, it would quickly be able to create the state representation and decide if there's any next action associated to it. So if we look at some code, um, an event is pretty simple. It creates a proposal. So here, if we try to draw a rectangle, we will use the event where, the mouse down event, and we'll create a proposal that we want to create a new rectangle, because that's what we know we want to do. And the unit of work then will initiate the model and will initialize a number of things within the model, and those things are completely unknown to the action. And that's why you want to differentiate between proposers and acceptors, because proposers only translate the event into a proposal. They don't know much about the model. They don't know much about what's going to happen next. And then the model doesn't know really much about why you want to create a new event, who is asking for that. All it knows is focuses on what it means to create a new rectangle, and that's it. And here you can see the code is extracted from a little game that I created that's available on GitHub as a sample code for the SAM pattern, where the rectangle is actually a net, and you're fishing some randomly located fishes within the canvas. And so what I do here is I initialize also the number of fishes the selected fishes to be to say that we're starting a new fishing event. Now, once the model is mutated, what the state function is doing is creating the new state representation, and it's going to basically draw the rectangle. The view will then display the state representation. It's using a theme, which is just a series of components, and it's using the state representation to render the particular component. And then the last step is the next action predicate. In that case, there's a next action each time, because we want to compute what are the selected objects. And interestingly enough, we actually go through another update. This action select object presents data to the model, and then the state representation updates the number of fishes that you've created. And that's pretty much it. This is how you decompose your code, how you factor your code using SAM. It's very straightforward. Proposers create proposals. The model accepts those proposals as a unit of work. The state representation, the state function creates the state representation and computes the net action, and you're done. And a lot of people have expressed how simple that factoring is, but how powerful it is, and it fits in literally one line of code, and this is all you have to know when you use the SAM pattern. Another concept that's important, that's a consequence of using the SAM pattern, is that there is a notion of step. And again, Dr. Lamport has noticed over the years that programming languages don't define a notion of step. What is a program step? Is it counter equal counter plus 1? Is that a step? And in reality, it's not. And where SAM is very useful is now it has a notion of step, and it can detect whether an action is allowed in a step. In other words, the state function, for instance, can produce the list of allowed actions, and at any given step, we'll be able to decide whether an action is allowed or not. So we don't have as many subscriptions to manage at all in some ways. But what's interesting is we can also compute what are the allowed proposals in a given step. In other words, we could trigger multiple actions, and it's only until one of them successfully presented a proposal to the model, then the step gets locked and all the action proposal gets ignored. So you could have a query that goes to a backend as an action, and then you could just change your mind and cancel that query. And the way you cancel it is you actually present a proposal to cancel, and when the query returns with the data, it can no longer present its results to the model because the step has moved to the next step. So all those concepts almost come for free for using SAM, whether you want to use load actions, load proposals, understanding where you are, in a particular step, and that leads to time travel. Now you can go back to a specific step in time because you use the SAM pattern. The SAM pattern itself is a unidirectional data flow with a single state tree. Just like Redux and Flux. Again, the React has been extremely innovative. It showed the way on a number of concepts. What I don't like about React is what it has grown to. It has grown to a complex set of libraries that change, and you need lots of stuff in order to build an application. When in effect, when you use SAM, you achieve pretty much the same result, but without anything, just the right factoring using proposers, acceptors, and learners. Another big benefit of SAM, because you don't need a library, is that all the code you write in SAM is purely isomorphic, and you can decide at a later point in time whether an action needs to run on the server, whether the action's in the model, or the model alone, or the model and the state, etc. You can basically decide what runs on the server, what runs in the browser, and that's very, very powerful because those decisions can be taken at a very late stage into the project. Even after the first version, you can still move your code from the browser to the server or from the server to the browser. Another important question is, where do you put API calls in the pattern? And SAM makes it very clear. If you have queries, you can put them in the actions, possibly in the model as well, but they fit really well in the actions. The result of an API query would then propose data to the model to capture the result of the query into the application state. Now, if the application state is mutated in ways that has side effects to the state of your system, and you want to persist that state, those API calls, the create, update, delete API calls, can be directly made from the model, because what happens is they often have a result that could impact the application state, and it wouldn't be necessarily easy to render a state without knowing the outcome of those operations. You can also put those API calls in an app function as follow-up action in a way that's similar to Elm, but it gives you a choice. And in my opinion, a lot of time you will end up putting them directly in the model, because you need to know the results of those calls before you can render the state. Conclusion, SAM programming model is focused on mutation. We're unapologetic about it. I think FRP is not going to provide front-end architectures that will be easy to build. We see that already today with Cycle.js or even React and Redux. SAM is based on a single state tree, and that's very important. Redux, for instance, is using sagas that breaks that principle. There's some state in sagas, and now it becomes a lot harder to reason about the state of your system. SAM is focused on what's allowed. It's not focused on managing subscription. Again, that's a strong departure from where FRP is going, which is thinking of streams and events. Here we just think about what are the allowed actions, and that's it. In SAM, the view components are 100% decoupled from the application, the business logic in your application, and SAM is aligned with functional HTML principles, which I think will overcome and take over all the template approaches that we see today. SAM is agnostic to any kind of wiring. You can use simple JavaScript function or just about anything you want, including React.js if that's what you want to use. From an architecture perspective, SAM is extremely friendly to side effects. Because we focus on mutation, we don't need as much purity as FRP. Introducing new concepts such as action hangback and cancellation because of its step-based architecture. It's truly isomorphic, and it even allows third-party actions to be wired in and present data to your model, say with OAuth token. So if you have any questions, you can visit the patterns home at sam.js.org, or you can join the discussion on Gitter. We have a SAM room, and lots of good discussions are going on, and we're happy to answer any question you have and get you started using SAM. You can use SAM with just about any framework or no framework at all. It's your choice. It's just a pattern, but we believe it will change the way you think about front-end architecture. Thank you.